Good afternoon, everyone. Welcome to our new session, Migrate to Serverless with Pulsar Function. This talk will be given by Axel Sirota. He has a master's degree in mathematics with deep interest in deep learning and machine learning operator. Now let's welcome Axel to give his talk.
Okay. Hello, everybody. I think it's good afternoon for you. It's good morning for me. It's the start of the day. I am Axel Sirota, and I was interested in bringing to you the power of Pulsar Functions, which were introduced in Apache Pulsar 2.0. So I will share my screen, and I will hope this works. I think it should. Okay. You should be able to see my screen. Jennifer, can you confirm me if you see my screen?
Yes,
excellent.
Yeah.
Okay, excellent. At any point in time, if you do want to ask a question, I don't know if the Hopin platform allows you to do so, but if Jennifer, you could tell me if there is a question in the chat, I would be more than happy to actually answer it. If not, at the end, I will check the chat for all the open questions. So let's start. So first, a brief summary of who I am. Right now, I'm a machine learning research engineer at Jump, which we work in the ad tech industry to use machine learning to find the best ads for each ad set in the traffic of 1 billion UPS per second. I create data machine learning courses at Pluralsight, the skills platform. So here is a QR link in case you are interested in searching one of those. I also create live trainings for O'Reilly Media, the publication. Here is a QR link to my trainings. I do technical revisions of books for O'Reilly Media, and I also do consultation. So let me give you a roadmap of what we're going to do. We will check a simple scenario, which we will be most familiar with. We will introduce Pulsar functions and how they solve this problem. We will develop them. And then we will check how to migrate in a simple checklist. So let's start. Let's suppose we run an e-commerce company, but this is just an example, right? And we have some invoices. For example, the customer Anna has 28 years old and paid $50, or she wants, whatever. So then, in our world, usually what we do right now is we have to import it into Apache Pulsar. So we import it into an orders topic. And then we first need to split it by commas. So what we need to do is have some function or run some code to get each of the messages and split it. And then that is to go to Postgres. So we use Pulsar as a middle ground between the persistence and what is our streaming of data from our e-commerce company. And the main problem here is that this is usually Lambda is the serverless scheme, or it's a full microservice, which if we think about it, it's really simple, but it still needs to be a microservice because we need to execute this code. Now, what are the drawbacks of this approach? The first one is we need to develop a full service to handle the splitting of invoices, which is a really simple task. The second one is then it is complex to maintain, because suppose that now we are not having commas. We are having dots. We are having an extra field. We need to refactor our function, which is, I don't know, 1 day of work. And then we need to go schedule the deploy, ensure that deploy is consistent with the rest of the architecture, ensure that all the versioning is correct, such that we don't deploy ahead of time because, for example, we deploy our new version with our new field, but the PostgreSQL table wasn't correctly migrated, so then we would have a failure there. So it is complex, the maintenance of the system. And of course, the other problem is that we have this microservice or Lambda that needs to authenticate and communicate in and out of Pulsar. So that adds a drawback on the performance. because all the messages need to go out, be parsed by this function, let it be microservice or Lambda is the same, and then go into Pulsar to use some kind of stage to the migration into Postgres. Because also we cannot actually do the real-time dumping into Postgres. Well, sometimes we do, but sometimes we need to batch it in order for the performance of our whole application. So overall, it's like 2 weeks of work. And this is just a simple example, but there are more complex ones that I am pretty sure you will find in your own organization or your own use case. So let's introduce what are Pulsar functions. And Pulsar functions are lightweight computing processes that actually do processing inter-topic. Therefore, the easy part is that we do not need to actually deploy something extra, and we can debug them in real time. Also, then, we do not need a full microservice. We just have this piece of code that we execute magically, and the inputs we get from one topic, the outputs will go to another topic, and we can do all sorts of things, like, and we will see those later in these slides, right, to redirect to multiple topics and do batching, routing, processing. And as I mentioned, they even have the functionality of having this bunch of code that I want to deploy, and you can even get them into what is called a local run mode, and then you deploy them, but you actually hook them into your own debugger in your own machine, so you can debug in real time what is happening. And that is extremely useful to know how it works in production, or let's say staging, because you don't want to debug production sometimes. And it's extremely simple how to do them. You just have to define your function. This is Java, but Pulsar functions support Go, Python, and Java. And we have our function split by commas. It's a simple function. This function, by the way, that I am implementing is the normal Java 5 function API. It's not a Pulsar specific right now. And then we deploy it. We have the Pulsar admin CLI, and we say I will create a function from this jar that I packaged my own function apply of that splits by commas, and I specify the input and output topics. That's it. This is 2 days of work at most. So we simplify the whole workflow by a whole lot. Overall, the pattern is that we have all these topics on the input, and then we can have a Pulsar function in our Pulsar deployment, such that then we can process all of those and send the result processed message into an output topic. And also we can send all the logs to another topic, and so on and so forth. So we start having all this complex mesh of topics being interconnected by Pulsar functions in our Pulsar deployment. And the whole Pulsar deployment becomes more flexible and more capable. So the big question around that poses is, didn't we have AWS Lambda for this? Well, of course, but first, we would still need to authenticate in every Lambda call. That's time, that's processing time. But also, let's imagine one use case, which is the use case that I have, for example. So I will bring it out to you. Let's suppose you have to process a real-time bidding system. A real-time bidding system is the place where you need to process every auction that comes from mobile, and let's see what happens. In this pipeline, we have American billion auctions per second. So each one of those is a request that we need to process then in our data pipeline. That means 2.6, the real trillions, the times 10 to the 18 auctions in a month to process. Every Lambda function is charging us $0.2 per million processes. This means $525 billion, not American billion, the times 10 to the 12 dollars, only to process that into another topic. It's ridiculous. And we didn't include the transfer cost of all the data being transferred into and out of our availability zones. What happens is that AWS Lambda is an excellent tool for serverless, but it's an excellent tool for small scale. And this is largely studied in the internet. You can check a bunch of documentation around this. It's so expensive that you cannot use it for a data pipeline that actually handles billions and billions of data. When we migrated to Pulsar Functions, the cost started to be $100, $200, just the EC2 cost of having that Pulsar function running all the time into topics. It was amazing when I found this. How do we develop them? Extremely simple. If we want to use the full functionality of Pulsar Functions, we just import the function interface from the Pulsar Functions package. Then we need to implement one method, process. This will be the method that will be called every time. We have a context object within that process. With that context object, we have access to the state of the function. So we can use the logger. We can actually send metrics, send debug metrics. We can send messages to another topic. We can do a bunch of things with that context object. This is the magic, really. And here, for example, what we are doing is we are fetching an input. We are getting the price from that input. And then we are sending it to another output topic, which is different from my defining the deployment output topic. So we can deploy to extra topics, doing a routing example. The return value of the function is the ones that will go to the output topic. In this case, I didn't care, but we could do anything we want. And we deploy this as we saw. We define the input. In this case, we didn't define the output. And we say what is it, and we package this function and just send it to Pulsar. Extremely simple. With all of this, and I expect that I am still with a good bunch of time because I left a lot of time for questions. In the end, this was the key part is the questions. We can do the migration into serverless because let's remember our case. We had our invoices, those were in the orders topic, and we had this microservice to send into Postgres. Okay, but now we can have that microservice can be replaced by a split Pulsar function. So everything is within Apache Pulsar. The only thing that we have right now is that import process and the dumping process in and out of Pulsar is also another application or a script to send it into Postgres and from the invoices. Okay, but Pulsar Functions also support a mode to integrate with in and out the Pulsar function, which is called Pulsar IO. So we can have a file source and a Postgres sink, and every part of our application now lives within Apache Pulsar. This is what is enabled by Pulsar Functions. It's amazing. So as a catch-up of that, Pulsar IO enables us to have many sources and sinks that can connect us to the rest of the world. This is very much like Kafka, for example, if you are used to that. They are Pulsar functions themselves, so they have the same mechanism, and we can even debug them as we do with Pulsar functions. It's amazing. And therefore, what we have is that every part of the processing of our application can happen within Pulsar. Since we get in some, for example, in some log, all the invoices, those Pulsar will get all of those, process everything in Pulsar, and then send that into Postgres. And we have maybe half of our e-commerce application, at least a part of the persistence, everything in Pulsar. And do not mind that you can also have other parts of the application, like, for example, doing some calculations. So how do we migrate to serverless? It's actually pretty easy. What we need to do is first migrate the processing logic to multiple Pulsar functions. This is simple because each function can be wrapped into a Pulsar function interface. Then we can switch all the I/O logic that interacts with the outside world, like HTTP requests, I need to dump into this database, I need to make this query, and that can be switched for Pulsar functions and sinks. Then all the logs get connected into a log topic. And as fast as you can check, you have migrated to serverless. You don't have any microservice, and you have a full application running in your Pulsar cluster. Even if you are already working with Kafka, there are tools to migrate from Kafka to Pulsar with zero code changes. So we can even have that step already get into Pulsar. So thank you very much. This was a slight presentation of Pulsar Functions and what you can do and how we can migrate to the serverless scheme. And I hope it was interesting. And any questions?
Thank you very much for sharing the detailed information about Pulsar function. From your talk, we can feel that your love on Pulsar functions, Pulsar function is really amazing. Yeah, and we can feel that from your words and sentences. Yeah. So I have a question that have you ever met any issue when you use Pulsar function and Pulsar IO, and how you solve it, or do you have any advice for other people who are using Pulsar function and Pulsar IO?
Well, yes, actually in Jam, I pushed everyone to use Pulsar Functions. When I arrived, they were using AWS Lambdas and they were paying more than 30,000 for a small part of the pipelines. Of course, they weren't using at the top where I explained my, let's say, example of how much you can expand, how much it can cost. So basically, the first thing I did is migrate everything, all the Kinesis pipelines and all the Lambdas into Pulsar Functions. We moved everything into Pulsar, Apache Pulsar and Pulsar IO, and we decreased the cost by a whole bunch. Also, the performance increased because now everything is within the same platform. So at Jam, we do it. I know Mercado Libre, which I was consulting with them a little bit. They are doing it. I know a lot about the local companies in Argentina.
Yeah, from your talk, we can see that Pulsar function help you benefit your work because it saves time and energy and make it more efficient. So so other people in other companies are also using Pulsar function, and sometimes they found they have to use too many Pulsar functions, and it will be hard to manage so many Pulsar functions. So we also have idea to develop a Pulsar function mesh to simplify this process. So do you have any idea or suggestion on function mesh?
Well, I was going to mention exactly that. When you start having a lot of Pulsar functions, you can now, and this was something that was briefly discussed in the last ApacheCon, that there was introduced the Pulsar mesh, the mesh functions, and basically what they enable you, and I encourage everyone to look into documentation and start checking out those, to deploy, like, let's say, your whole cluster of function in an organized way, and so you can handle all of those easily. Recommendations as far as good practices or so, I wouldn't dare to have one right now. I encourage I am still in the investigation phase of the Pulsar function mesh. I was really expecting to incorporate them into Jam, see a real use case, and then bring it to talk to the rest of the community. But I encourage everyone to check the functions mesh because it's an amazing idea.
Yeah, it's really amazing idea, and we are excited that you would contribute to this. It's really pleasant to talk with you, and we really enjoy your talk because we feel the enthusiasm and your love to Pulsar function and to the open source project. Yeah, thank you very much for your contribution to Apache Pulsar. Let me check. So currently, if others have more question about Pulsar function and the function match, you can just leave your message here, or you can we encourage you contact with Axel directly, and you can have more conversation and understanding about our speaker. Yeah, I think it's really amazing talk. Yeah.
Thank you very much. Thank you everyone for for having me in this session and in this conference. And yes, of course, everyone, I feel free to contact me. Here is my Twitter, here is my mail, and I'll be more than happy to talk about Pulsar anytime.
Yeah, that's really cool. Yeah, keep in touch. And thank you, everybody, for joining us. Goodbye. Goodbye. Good morning. Yeah.
Good morning. Thank you.
Okay. Bye-bye.